move on to question 2, where we're solving another IVP, where it's y squared cos x, and our initial conditions at y is equal to 0, so x is equal to 0. You have half as your y is equal to half. So by just looking at this, you can tell that what's y prime. Y prime can be written as dy by dx, right? I'm saying right to camera. Wow. Anyway, so you have dy by dx cos y squared cos x. Now notice that there's a multiple here, so you can actually divide. This becomes a separable, so you can get the y squared to one side and cos x on one side. So basically, you can integrate both sides such that one side has only y's on it and the other side has only x's on it. This can be done simply by dividing the whole equation by getting this down here and getting this up here, which would in turn give you dy, 1 over y squared dy equals cos x dx. See, now if we integrate both sides, we will end up with simple values where we're just integrating for x and integrating for y's. You have to keep a note that generally this happens when you have a multiple going on here where y and x are being multiplied against each other and can be separated. This won't always be the case, but it's something that you should keep an eye out for. So you can go forward with this by saying integrating both sides. So that's basically just adding an integral. Now y squared, well, I'm hoping, it's a general assumption that you guys should know how to do this integration. So I'm just gonna speed through it. I'm not gonna explain it too much. This would give you minus 1 over y equals sine x plus c. Now a lot of people are gonna question why there's a c only on one side and not the other. You don't have, well, I've skipped a step in a way. You actually would probably have plus c on this side also, but you can take the c to the other side and basically combine them both to get one constant rather than having two separate constants in an equation. So basically, since we're trying to find a function of y, we would not want to leave it in this form. You'd probably want to make it in a form such that it's y equals to something in the form of x. So we can basically inverse this, so you get y, negative y is equal to 1 over sine x plus c. Then you can actually get this negative to the other side, which would give you a negative 1 over sine x plus c. This could be done in different ways. You could actually distribute the negative down here if you want. You don't have to. I did here for simplicity, but that's again preference. It doesn't have to be one or the other. Now, if you know that y, now that we have an equation for y and we know the initial conditions actually, when x is 0, y is half, you can basically just go ahead and sub it right in. So you're going to get half is equal to minus 1 sine of 0 plus c. Now everyone should know sine of 1 is 0, which would in turn leave you with, I'll go right here, half is equal to negative 1 over c. Inverse them both and you get 2 is equal to negative c, basically. And that means c is equal to negative 2. Sub that into our first equation, which I should put a box around it. Wow, that's a pretty bad box. Anyway, so sub that in right there and you get y is equal to negative 1 over sine x minus 2. Now this could be also written as 1 over 2 minus sine x. Notice that they're the same thing. It's just basically distribution of the negatives. I'm taking the negative out of here and canceling them both. So note if you got this answer or this, it's the same thing. You don't have to worry. This might seem slightly more simple, and that's what they have in the solutions, but that does not mean this is wrong. So this is going to be your final answer for, or this, for question number 2.